In manufacturing, measuring the results of each process is vital to the success of the company. At Honda of America, they rely on statistical process control to continually monitor and improve their processes.
Statistical process control is simply monitoring the consistency and the repeatability of a specific process. It's not a complicated thing. It's really quite a simple approach to understanding what is the reliability of my process. An example of that might be torquing a bolt. In torquing a bolt, there are a lot of variables that can go wrong to cause an over-torque or an under-torque situation. In that example, if we apply statistics and understand the actual capability of the process, we can predict the failure rate within that process and make running adjustments so that we don't have actual problems occur.
Another example of Honda's use of data collection to understand its processes is the door closing speed test. This test measures how fast a door needs to be moving in order to close, but without slamming it.
Connie is preparing to measure the door closing speed on our four-door Civic. The purpose of this test is to measure the amount of speed that it takes to close the door based on a customer's perception. The first thing she'll do is she'll scan the VIN number into the Datamite. The Datamite is simply a handheld computer. She prepares the car by making sure it's completely sealed, and then she attaches the sensor to the rear door and the interrupter to the left side driver's door. She'll repetitively take readings of the door closing versus the door not closing until she gets within 0.1 kilometers per hour. The gauge reads in kilometers per hour. So when she reaches a point where she's within 0.1 kilometers per hour of the door closing versus the door not closing, that's the reading she records. It may take about 10 to 15 tries to get an accurate reading. She found her reading, and now she'll punch the numbers into the Datamite. The door closing speed data is input into the computer, and a statistical software package is used to analyze the data. We use SPC control charts to analyze the data. At the top is an X chart, or individuals chart. As you can see, the data is consistent and stable. There is no assignable causes present, only common cause variation. In addition to the SPC charts, we also use a histogram in order to do a process capability on this particular characteristic. The histogram shows a distribution of the data based on about the last 2 weeks of data. The CPK is a capability index that tells us how well we are at meeting our specifications. Industry standard shoots for a CPK of 1.33, and we are currently meeting that.
We have a number of different ways that we collect data or do statistical process control and monitoring. Those range from equipment that automatically collects the data to a manual process where the associate's actually taking a reading and plotting it manually on a chart, to a process where we may be doing some offline inspection and actually collecting data with some hand gauges. This data is processed in a number of different ways, but the most effective method is by the associate understanding what do they do when they're out of control, when they find a point or a measurement that is not where it is supposed to be, and then they take action on it on an ongoing basis. Waiting and analyzing the result after is not always that effective, but for continuous improvement, doing it as you go is what's important.
During the door closing speed test, a result came back that extended outside the upper control limit on the control chart. This indicated that for one door on one certain car, it took an unusually high amount of speed to close the door without slamming it.
This is an individuals chart, or an X chart, showing a plot of data of door closing speeds over a certain period of time. On the chart, you'll notice an out of control condition at this point, meaning there is an assignable cause potentially present. This assignable cause was investigated, and it was found to be a problem with the fixture used to install the striker. The striker was installed slightly offset due to a broken fixture. When the striker is slightly offset, it will cause the door closing speed to be higher than normal. The fixture was replaced, and the data fell back into control, and it was consistent and predictable once again.
By teaching their employees to understand statistical process controls and how to immediately counteract out-of-control situations, Honda prevents problems from recurring during manufacturing and is able to maintain an outstanding level of quality control.